Hey, today we're talking about chemistry and naming conventions. So chemistry has a language, and to understand many of the concepts well, you need to understand that language. It's like going to a baseball game and having no clue what a strike or a fastball or an inning is. It's just hard to appreciate that game. Today we're looking at naming for ionic compounds, molecular compounds, or sometimes called covalent compounds, and then acids, and we'll talk briefly on acids and bases. Okay, so first to tell between ionic compounds and molecular compounds. So ionic compounds are between metals, basically have bonds between metals and a nonmetal. And for a molecular compound, we're looking at bonds between a nonmetal and a nonmetal. And so let's take a look at the periodic table to just kind of get this straight in our heads. So if you're trying to figure out what's a metal, what's a nonmetal, all the stuff in yellow on your left-hand side, those are metals. And if you can imagine just kind of an imaginary line from boron to polonium, that's in purple. All that left side are all metals, and everything on the other side are nonmetals. So it should be pretty easy to figure out what's what. So the green portion shows some of the nonmetals. Something interesting to point out is the middle section is going to be shown in blue. Those are called transition metals. And those basically, a lot of these metals have more than one typical charge when forming an ion. Let's look at some examples. So some ionic compounds, look at like sodium fluoride. And so you have sodium, Na, and fluorine, F. So sodium is on the metal side, fluorine is on the nonmetal side. Or lithium chloride. Lithium is the metal, chlorine is the nonmetal. Some molecular compounds, P2O4, both phosphorus and oxygen are on the nonmetal side, and SO3, or sulfur trioxide, both sulfur and oxygen are on the nonmetal side. So we're looking at nonmetal and the nonmetal. So this is a really easy way to figure out, okay, am I talking about ionic compounds or molecular compounds? Let's dig into the details about how to name it. Okay, so before digging into ionic compounds, let's take a step back and look at atoms and ions. Okay, so this is an atom, and you might recognize this. This is a helium atom, and you'll see 2 protons, 2 neutrons, and 2 electrons. What happens as you remove an electron is that you get something called a cation, and it has should be a net positive charge. And when you name it, it's pretty simple. Basically, it's the name of that metal, and then something ion. So if you're looking at potassium, and if you took off 1 electron, then it would be a potassium ion. Calcium would be a calcium ion, and aluminum would be an aluminum ion. So for a lot of metals, it's very simple. For certain metals called transition metals, remember in that blue region we showed earlier, it would basically be almost the same thing, except it would be the name of the metal, and then in parentheses a Roman numeral with the charge, and then something ion. So in case of iron, it would be Fe3 plus, it would be iron 3 or iron 3 ion. Okay, let's take a look what happens when you add an electron. So if you add an electron, now you have something we call an anion, and has a net negative charge because of the additional electron added to it. And so in this case, you would just basically add a slash or IDE as a suffix. So fluorine would be fluoride, oxygen would be oxide, and sulfur would be sulfide. So with this little refresher on the atoms and ions, let's look at naming ionic compounds. So if you can imagine kind of 3 parts to it. So you would have the first part would be the metal, or it could be a polyatomic ion, and then Roman numeral, and this is only for transition metals. And so most of these have more than one typical charge for their ions. And there's an exception. There's 3 exceptions. One is silver, which always has a charge of 1, cadmium, which has a charge of 2, and zinc, which also has a charge of 2. And so there's that middle section only for transition metals, and then that third portion would be the nonmetal with a suffix of IDE, or a polyatomic ion. And so it might be easier with an example. So take a look at this. So sodium chloride or potassium sulfide. So it's basically the metal and then the nonmetal. And let's take a look at two transition metals. And so the first would be FeCl3, or iron 3 chloride. And then you see silver, or Ag2S, and you're like, wait, where's the parentheses in the middle? And so silver, remember, is one of the exceptions, and so always has a charge of +1. And so in this case, it's just silver sulfide. So when you think of these polyatomic ions, you can almost, some people represent it differently, but you can imagine it as, this group of covalently bonded atoms, and they always act as a unit, and that whole unit acts like an ionic compound. And so in this case, I drew a sulfate ion, and also you write it out. We can write it out in symbols. It would be Cu2+, that'd be the metal ion, and the other side, SO4 2-, would be your polyatomic ion. And the name you would give this, you would call it copper sulfate, copper 2 sulfate. Okay, let's take a look at naming molecular covalent compounds now. And these are different because they, instead of giving up an electron or gaining an electron, they actually share the electron. And so we'll talk about covalent bonds later, but for now, to recognize it, it's basically, when you see a nonmetal with a nonmetal, we're talking about covalent compounds or molecular compounds. And one of the keys to this is knowing your Greek prefixes. So let's take a look at this. You remember mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, and it goes on. So if you kind of jog your brain and remember all that you learned in geometry, it kind of makes sense. Okay, so let's do an example. This is dinitrogen tetraoxide. And actually I spelled that wrong. It should be tetroxide. And just note that when you have a prefix that has a vowel, an element with a vowel right next to it, you drop that vowel on the prefix. The exception would be with di, and in that case you leave the di. And in this case, dinitrogen tetroxide is N2O4. Okay, so if you look at how this looks, basically you have a prefix, and so it'd be like, in this case you would not, if it only had one, in this case, if you only had one nitrogen in our example, instead of writing mono nitrogen, it would just be nitrogen. And so it crossed off the mono. But if you had di, tri, it would be di or tri something. Let's take a look at that. And then you would have your first nonmetal, and then you have your second prefix, and then your second nonmetal. So for P2O4, this would be diphosphorus tetroxide. And so notice that I crossed off the A on that. And second, if you were to look at OF2, what is that? Well, there's only one oxygen, so we're gonna drop the mono on this, and we're just gonna put oxygen difluoride. Okay, let's take a look at acids and bases. And today we're just gonna look at a simple case. These are called Arrhenius acids. And it's a very simple definition that will probably cover most of what we'll use in this class. And so acid basically is something that would tend to increase the concentration of hydrogen ions or hydronium ions. And base is something that would increase the hydroxide ion. And we're looking at first at binary acids. So bi meaning two elements. It'll have a form that looks something like this. So it'd be like hydrogen, and those X and Y's would be some number, and A would be some nonmetal, something with a suffix of IC or ic. So it'd be like hydro, and the way you would name it, it would be hydro something ic acid. And so if you look at our two examples here, you have H2S, and so S is sulfur, and so it'd be sulfuric, so it'd be hydrosulfuric acid. And HBr, Br is bromine, and so if you add the suffix IC, it would be bromic, and if you name the acid, it would be hydrobromic acid. And so whenever you see the hydro, that's just a cue to you that there's no oxygen in that acid. And those X and Y values, you may remember from our discussion earlier that those, because we have neutral compounds, that those should help to balance the charges of the cations and anions formed. So in the case of H2S, it would be, since sulfur typically has, the sulfide ion has a charge of 2-, and hydrogen always a +1, you'd have 2 hydrogens for every sulfide ion. Okay, let's look at oxyacids. Oxyacids basically have an polyatomic ion with oxygen in it. And so the general form you have is something like HX, which hydrogen something, and then a polyatomic ion and some quantity of that. So one of the keys is you have to know your eights, and I'm listing them out here. You have your sulfate, your phosphate, your nitrate, your bromate, ClO3 is your chlorate, your oxalate, your carbonate, and your chromate. And so if you look at these, you should recognize these symbols and also recognize the charge that's typically associated with this. And you'll see why this is useful as I go on to the next step. So as you're looking at naming for the ions and the acids, if you have ClO3, so hopefully you remember that's a chlorate. And so to name the acid, it's just chloric acid. An easy way to remember that is that I ate too much and got sick. So ate and ick. So whenever you have a chlorate, it's a chloric acid. And for ite, or ClO2-, so all the ites would have one less oxygen atom, and it would be chlorite. And the acid would be called chlorous acid. And then you have two other cases. The first is where you have one additional oxygen above the 8. In this case, chlorate is with one additional oxygen would be ClO4 -1. It would be per chlorate. And so that per is short for hyper, or above that. And if you had one less than the chlorite condition, ClO-, it'd be hypochlorite. And naming the acids should be pretty obvious from there. So for the perchlorate, it'd be perchloric acid, and for the hypochlorite, it'd be hypochlorous acid. Let's look at NO3-, and so in this case, you should recognize this to be a nitrate ion. And so now when you're looking at NO3 is a nitrate, the acid is a nitric acid, and same thing with one fewer oxygen, that was a nitrite, and the acid is a nitrous acid, and you can fill in the rest on your own. Okay, well hopefully that was helpful and you understand a little bit more about some of the basic naming conventions